right, welcome everyone to this week's IPLD sync meeting. It's November 11th, 2019. As every week, we go through the stuff that we've done and that we plan to do, and then discuss any additional items we might have. I start with myself, and so in the past week, actually this was just today, it came up, there's still this discussion about SERDE and tag support for file formats. I came to the conclusion that for IPLD, there's not really a point using SERDE because, well, we need a change that they don't want to do upstream. And I also looked into perhaps SERDE could be extended and we still have our stuff working with the rest of the SERDE ecosystem, but it's just not possible in Rust currently. To extend another third-party library in a way that we need to, and it's still compatible with all the other stuff. I've asked on the user forum, got one reply, which was they're discussing things, but it doesn't seem to be possible. And my plan still is to write a blog post about it because the Rust community has a call for 2020 to say, what things do you want to see in the next year for Rust? And my item would be, I want to be able to extend a third-party module somehow. Like, it doesn't need to be nice, it just needs to be some way. And this, yeah, so we'll see if they pick it up or not, but that's my plan. But related to this, the author of the CBOR crate discussed on the issue and pinged me that he still would want to have tag support. And now the idea is that he might fork SERDE. And the way it works is when you compile it normally, it would use the normal SERDE and you won't have tag support. But then you can add additional line to your project and then it will use this fork, which is tag support, and then you will have tag support. But the other modules will still use this forked version and basically just work. That's the basic idea currently. I'm unsure if this will work because I think if you do this way, you can't publish those modules publicly, so you can only have them in GitHub repositories, but we'll see. But anyway, so the long story short is there's still discussions, and I would like to help him because like my hope would be that we find some way to make it work, and then hopefully convince other people doing it the same way. And then in the end, again, convince the original SERDE authors that, well, if those 5 people are using the fork and not the original one, why not making it upstream? But yeah, we'll see. But certainly my plan is to also basically have a plan B and just not using SERDE, but just, yeah, using IPLD directly. But it's kind of like the, I don't know, like a background thing I'm working on or like help with, but it's not like the top priority because, as I said, it's unlikely that it will go upstream. Then some other great news is that the stack specification, it's some geo standard that I've been involved with a bit. They have an extension for checksums, and I convinced them to use multi-hash for their stuff. And it got merged. So in the next release of the spec, which will be like in end of the year probably, they will have using for the checksums multi-hash. And the great news is because they also plan to get it into as an official OGC standard, which is like the major geo standardization organization. And most of the OGC standards also become ISO standards. So basically, this kind of like this way kind of multi-hash bubbles up into an ISO standard, hopefully. So it's kind of like, that's pretty cool, I think. Yeah. So, and then on the Rust side of things, I've looked into, as I said, I want to make the Rust stuff also work without this sort of stuff, is I looked into the ecosystem, what we have, and I just found out that we have, so Protocol Labs has a Rust multi-hash project, but the libp2p team has forked it for libp2p. So libp2p is not using the upstream project. So what I currently do is I backport those patches to make sure that basically libp2p and whatever we have use the same version. And yeah, so as some background information, the reason is, so the libp2p Rust version is mostly done, or exclusively even done, by folks from Parity. And so it's not by Protocol Labs. And therefore it was just easier for them to fork it. But I know one of the main developers well. We've met several times in the past in person. So it's basically, it's a friendly fork. It's not like they want to do something fundamentally different, but it's just, it was faster for them to move forward. So it shouldn't be a big problem to, and they even have an issue open that they want to go back to upstream. So, but that's what I'm working on. Yeah, it's not, it's actually more exciting than you would think, because it's basically, you make huge progress because you merge those upstream patches and get them reviewed with one click, and yeah, make big progress. So that's kind of nice, but it's not like mentally challenging. Yeah, that's all I have. Eric?
Yeah, sounds like you've had lots of standardization stuff. So I'm still hung up on rabbit holes in CodeGen and trying to prepare things to be optimization friendly, which is kind of where I've been for a while. And things are getting a little more resolved, but also just turning up more and more questions. I can't remember exactly what was the last update I delivered, so I might backtrack a little bit and make sure that I provide context in one go here. So when doing performance optimization at all, memory allocations by count usually, rather than by size as well, are one of the most major issues. So I've been worrying a lot about how to design the system to amortize allocations as much as possible. In the last couple of weeks, I've learned a lot more about the compiler internals, and particularly one feature that turns out to be relevant to us is, so we end up having lots and lots of things escape to heap because we want to handle them via interfaces. Like all of our traversal code, the selectors, a bunch of our cool features like that, they all work because we can turn everything into a node interface, monomorphize it, right? But for things to be held as an interface in Go, they have to be a pointer. So they have to be, it almost always implies that they have to be on the heap, but they definitely have to be a pointer. So one important thing that I've learned recently is that once you have one whole structure that's on the heap, getting internal pointers into positions in that same structure is essentially free. It will not cause more heap allocations. So the good news is this gives us a way to do lots of amortizations. The meh news is we still have to make sure to design the internals of the code to actually do large extent allocations up front and then be able to pluck those pointers out. So this is still easier said than done. And this turns out to kind of actually get in conflict with some of the interfaces that we've already got. So in all of the code to date, like from some of the very earliest drafts, so we've had the node interface and we've had the matching node builder interface. And the node builder builds up some value, and then when you call the final build method on it, will return a node that is supposed to then be read-only. And so the overall semantics of the node builder interface is you build some small value and then you build a bigger one and you fill it with smaller values and then you build up this way. And this is almost exactly the opposite of what we want to do for efficiency, because we want to start with a large extent allocation and then fill it in. So it turns out that the interface itself is just going the opposite direction of the way that the internals want to go if we want them to go fast. So the good news from the last couple of rounds of research is, given a bunch of this knowledge about internal pointers and stuff, we can do a bunch of optimizations, but figuring out how to make those play within the interfaces we've currently got is still extremely challenging. And one possible way forward would, for example, be having both the node builder as it currently is, which builds up from smaller to bigger, and then maybe build another interface in parallel, which does this extent allocation and then fills it in. And so that would be one option, but it would increase the amount of surface area of our code kind of substantially, and that's a little, I don't know if that's a good idea. And another design that I've been trying to flesh out is if we can have the innards doing the extent allocation, but then do something that has almost the same contract as the node builders already do. And I think the answer to that might actually be yes, and that's the model I've been trying to work on for the last week or so. It gets really interesting, but I think with a sufficiently well-defined model of visibility where you only reveal pointers to some part of the large extent when that section of the extent is finalized, I think it's possible to do this all in a safe, immutable way. But it's just gotten increasingly complicated, and it would also come with some very interesting constraints around if you use the get child builder for field method on a node builder. Currently, the thing that returns you is supposed to work within the bounds of the type, right? So if you're asking for the builder for a field and it gives you the type foo builder, you should ostensibly be able to use that thing more than once to build several instances of foo. And if we try to do the extent-based allocation stuff, then we could actually cram it all into the same interface, but we would end up with that child builder that you get for the field. Because it would be binding to existing memory, it would no longer hold that contract about being able to be used to produce more than one value of that type. This is probably more detail than I should be going into right now, but so basically lots of questions about what the sane interface is for that. And so if somebody wants to talk more about that later, I think I need more than one opinion. And I'll leave it there. I see Rod wincing. Yeah, sorry. That's the correct reaction, though. It really is. If nothing else, I'm working on a big documentation about things I've learned about the Go compiler and memory layout. So that might help.
Have you figured out where you're going to put that?
My current draft is just sitting in the CodeGen directory. I don't know if that's its final resting place, but and yeah, I think that's about it. I'm really enjoying, by the way, reading the huge amounts of documentation you've been working on, Rod.
Cool. Then next one is Rod.
So aside from the documentation, which I finished off last week, well, I finished off the bulk of it last week. And that's, I'm happy for that to sit in review for a little while, but I really would like to consider getting input from outside the team. So identifying someone or someones that could have a look at it, and if they can figure out what we've been doing for the past few months from the document, then that's a win. That means it's doing what it's supposed to do. So I don't know what the process is there. Maybe we merge it and then get someone to review it. Or maybe we get someone to review it in the state that it is now. I don't know. Anyway, but I'm glad that you guys are working your way through it. That's very helpful. Aside from that, I've moved on to, so I've had this itch that has been needing to be scratched for a few months now. I've intentionally disconnected myself a lot from browser JavaScript, which means that I'm not as attuned to making my libraries run in the browser, and my testing is all very node focused, and that's not very ideal. But but I'm also not satisfied with the state of testing library code in the browser. I've been, the last week, I've been deep in browser land and browser testing and Puppeteer and web workers and a bunch of other things. Upskilling, but also writing some little utilities to help test better in the browser and more efficiently than the options available today. And I'm using a JavaScript CBOR parser. I'm writing one as a way to learn that that stuff that I have gaps in, but also using that project as a way to become more familiar with CBOR as well. So it's been a week of learning, really. That's me.
Cool. Yeah, I also looked like, I think a year ago into the browser testing stuff, because I also thought that like the current way, like what we do in other JavaScript projects with like the Karma and whatever it's called stuff is just insane. Like
it's so heavyweight. Yeah.
Yeah, it's and so I tried to use like there's some I tried some library which uses the tab format basically, and you can just kind of like pipe it to the browser, which kind of worked. It was kind of nice, but I'm not sure if it really like the problem again was like the hello world testing works, but
anything novel.
The problem with browsers is it's more than this.
Yeah, that's really this is one of the main reasons I checked out of browser dev years ago, was the craziness of trying to make things that are compatible across browsers, but just testing that. Testing in the browser is just ridiculous, and it really hasn't improved that much, which is just the ridiculous thing about it. It's like, how are people satisfied with this? But everyone has their little hacks of getting around it, and yeah, I mean, Selenium is still state of the art, and I think the thing that we have is that we're in that middle area of, we don't care about end-to-end UI testing. We don't need to control a browser to test an interface or the DOM. We want to take library code and say this works in the browser. So it's a subset of what most people who are operating in the browser care about, and it's that area that's not served very well. If you want to do end-to-end, then there's a bunch of options where you can, many of them using Selenium in some form, a bunch of options where you can do that. It's just that then ends up too heavyweight for what we want. We just want to say, okay, I've got a library that I expect to be in a browser environment at some point, and I want to assert that my tests run in the browser. But I'm having some success on that end, so I'll publish that soon and get some feedback. But my plan is to go back over some of the more recent JavaScript stuff I've produced and adapt that with some browser testing, because I know, for instance, I'm leaning much more heavily on buffer than I should, because uint8 array does a lot of what we need, and if you can avoid buffer, and if you can avoid being the library that's responsible for pulling in the buffer polyfill, then that's a positive. But as a back-end engineer, I just don't think about those things. I just reach for the tools that are best. So just shifting my thinking, which is a good thing. So yeah.
Cool. Good. Is there anything else on the do you want to discuss? So I've just one question that just came up today, and I should put more thought into it before asking, but I'm so like, perhaps you've thought about it already, so I'm so keen to hear the answer. Is that when I reviewed the schema documentation stuff, is that the representation of, let's say, a struct Yeah, so you define in the schema the representation of the struct, how it should be serialized. But what if you want to serialize it for different formats differently? Why I'm asking this, so basically the background of this story is that, but so just what I figured out is the problem is that, for example, especially with structs, so in schemas we have records, so I would call them records, which is basically structs, so what do we call them? But in the data model, we don't have this. So in the data model, we only have a list, which is basically the thing where you would put records into. But the point is that, for example, in the WASM interface type, so it's basically an upcoming standard for exchanging data between things, is heavily based on WebIDL. I try to keep it short. So, and they basically don't really define a map type, but they only have a record type. Which basically means is in our world, it would be strange to transform it from the schema, from a struct into a map, then into a list, so we can use it then as a record type. Instead, it could directly be basically from our schema into the record type and everything will be fine. But the problem is, again, of course, if you transform it to JSON, you would use the normal map type. And it was just like something that basically came to my mind about like, yeah, is this something we like thought about, or yeah, is it just, we'll see.
A little bit. I think we might actually have a pretty easy, if not yet documented, path to do this, because we can just treat the schema as a document that we can do some transforms on. And so I think I had a very similar thought before when we were doing some of the selector spec stuff. We cared about the serial size of selectors a lot, but we still used maps for extensibility purposes. But so we had renamed a bunch of fields down to single character, right? But that's not what I want to see when I'm debugging. So I was thinking, what if we had a function that took one schema and transformed it into another schema and just stripped all of the rename instructions off? And interestingly, since those are representation details, that means the schema semantics are identical. So we can actually use either one of them on the same data very easily. So I think we could do a similar thing to make a schema suddenly conform to the WASI standards. We could just say, okay, take the real schema that we wrote first and then transform it into another schema where every single struct is annotated a representation tuple. I haven't tried to write any functions to do things like that, but it sounds like a thing we could do.
Yeah, it was just this sounds like a sensible way of doing it. It's, by the way, the same if we would transform it to Erlang. Which is like
Erlang doesn't have any maps.
It doesn't. So what it has, so this was a huge problem with CouchDB as it is in Erlang. So basically how they represent JSON is they have basically a list of tuples where the key is basically like a list of two tuples where the first element is the key and the second one is the value. And then, this is how they have a map. But well, it's more like in the functional programming world, you don't have really maps, at least in Erlang, which is a pain. But yeah, for those cases, so Pizzi, I was wondering. So I think it makes sense because I was wondering how tightly we want to couple the representation to the schema. Basically, is kind of like the question, or like. But if you can easily transform it, that should be,
And I think this is worth noting, and we maybe haven't yet, but if you're doing a transform on a schema that only massages the representation parts of it, then there are certain properties that necessarily preserves, which is cool.
Yeah.
So like if you had some other function that was going from schema to schema, but it was massaging some other things that were in, like if it was removing or adding nullable annotations, those would change the behavior, right? But if they're just massaging the representation stuff.
Yeah.
Yeah.
And we're going to get into trouble with all sorts of things where we're trying to adapt to specific environments, which is where if we're going to have to do annotations and that sort of stuff, like CodeGen is the obvious place, but this is an extension of CodeGen, really. There's basically, you know, we've got this nice layer, but when the rubber hits the road in all these different environments, there's going to be special cases everywhere. And I think we can probably adapt to a lot of them with different encoding formats, like coming up with a new DAG, something or other. But then others, we're just going to have to expose specific rules, and that's where it's going to get ugly with annotations, but that's going to be a necessary evil to make it practical for people, because a lot of consumers of this stuff are going to be using it in a specific environment. So that's all they care about. They don't care about the fact that this thing is nicely portable. No, I just want it to work in my environment, and I want all the goodies that come along with it.
That's true, yeah. Cool. Yeah, so thanks for discussion, because like that's, yeah, so I can sleep well tonight.
Simple man with simple needs.
Cool. Is there anything else? Cool. Then I say goodbye to all the thousands of people watching the live stream. And yeah, goodbye. See you next week.